So this is my lab 4. The purpose of this lab is to predict the behavior of circuits containing resistors in series and parallel using multimeters to measure the actual values of conventional currents and potential differences. It's also to examine the behavior of ohmic resistors and capacitors. As a preview for my findings, the experimental RC took 5.99 seconds, while the calculator RC took 6 seconds. So using GlowScript, this lab uses fundamental physics principles to model the motions, including Ohm's law, which explains how voltage equals current divided by resistance in an electrical circuit. The node rule says that the total current into a circuit equals the total current out, and the loop rule says that the sum of all the voltage in a loop is 0. Also, we note some formulas regarding the potential difference of a capacitor and capacitance. So the experimental model uses an online idealistic model of a circuit to show different configurations of resistors and capacitors. The system is the circuit while the surroundings is everything else. The initial conditions are that the circuit has two 1.5 volt batteries, two resistors at 47 and 100 ohms, and two ammeters. In this experimental model, we assume that the resistance and the emitter of the wires is negligible. We also assume that the EMF equals the potential difference of the capacitor plus the resistors. So the actual reading was 0.02 amps. The potential difference is 3 volts, and the current is 0 amps. So in this part, it was an open circuit where there's no current, and the potential difference across the opening equals that of the one across the power source. Then the circuit was closed, and the potential difference is found across each segment. So using the loop rule, the trip potential is 0, and the current was 0.02 as expected. So the ammeter reading doesn't change because the voltmeter has a very high resistance, and this means that the current doesn't flow through it, and the path of the current in the circuit remains unaltered. Then the ammeter is put in parallel with the 100 ohm resistor so that the current reading increased to 0.06 amps. For part 2, I found the potential difference across the capacitor as a function of time over 20 seconds with a 9 volt battery, a 200 millifarad capacitor, and a 30 ohm light bulb. So using the Ln equation, the slope of the line of best fit for the data was -1 over RC, which was equal to -0.168, and this led to a result of 6 seconds. So in order to calculate accurate values for an ideal circuit, the wires and ammeters in the circuit must be conducive enough to have negligible resistance. Also, currents and voltage at different points in circuits with capacitors and resistors are time-dependent and decrease exponentially with time. Sources of error include that an idealistic model of the circuit was used, so there was also likely human error since the timer was not entirely accurate. To further think about the physics concepts in this lab, we can look at the discussion questions. So for the first one, if this was the case in real life, the ammeter would have had some resistance, and because of this resistance, the reading for the current would probably decrease as resistance in the ammeter would contribute to a lower current. For the second question, if there was no resistor in the current, our ideal model would have the capacitor reach full charge immediately,